So, Kushagra, the Microsoft Olympus project is out, and you've got servers that are 50% designed, and you're asking for help to finish them.
That's right. It's very exciting.
Yep. And the roadmap is that in a few months' time, we'll start to hear about who else is involved.
Yeah.
And then in how many months till the servers are finished?
Yeah, sometime mid next year.
Mm-hmm.
So the plan is, we released the specifications and collateral today,
Yeah.
Which is November. By March of next year, we should be in a position to announce the ecosystem of partners, and by mid next year, the design will be done.
Right.
So between now and mid next year, which is roughly about 7 to 8 months, that's the time when the community and the industry can join in and start to help with building out the ecosystem of the building blocks.
Okay. What sort of sector companies are you after? Are you after chip makers, server makers, motherboard makers, or everybody?
All of them.
All of those?
All of them, yeah.
And network companies?
Not networks, mostly server and storage.
Right.
Yeah, so the idea would be to have different design points, so that when you think about different applications that are run in the data center,
Yes.
how do you have a solution to meet any requirement that will come up
Right. Okay.
on storage or compute?
Right. And these servers will fit into OCP open racks?
Yeah, it's very flexible, so they could go into a 19-inch rack, they can go into a 21-inch open rack. It's up to the end user of how they want to deploy it.
Right. Even potentially the LinkedIn Open 19, subject to them being interested.
Yeah, it's very flexible, so people can take it and adapt it.
Okay.
To fit into any kind of rack.
A lot of the open rack specifications use DC bus bars, but yours uses AC.
Yeah, that's right.
Is there a reason for that?
Oh, there's two reasons. That's a great question, by the way. It's very few people have asked me something.
Yes.
So the first one is efficiency, and the second one is phase balancing.
Okay.
Which nobody talks about, but it's very important. So the efficiency. So you have 3-phase power in the data center.
Yeah.
And you need to get 12 volts at the motherboard.
Right.
The question is, how many conversions are you going to do?
Yes.
From the 3-phase in the data center to the 12 volt on the motherboard.
Right.
Now, and what is the efficiency loss you'll have along the way? Right. So what happens with the bus bar is that you have the I squared R loss because you're sending current over a long copper wire.
Right.
So essentially, you're wasting heat, which is efficiency, right?
Right.
When you do 3-phase distribution to the whole rack,
Yes.
all the way inside the server,
Yes.
there's only one conversion that happens from the 3-phase to 12 volt. And when and the power supply is 97% efficient, so essentially it means that between the data center and the load,
Yes.
you only have 3% loss. So that's the first one. The second one is actually more interesting.
Yes.
And that's the need to do phase balancing. So most people try to do phase balancing by doing like a server 1 is A, server 2 is B, server 3 is C, that kind of thing. But the problem with that is that the workloads are different on different servers. So the server on the phase A could be running at full load.
Oh yeah.
The server on phase B could be running at 50%.
Yeah.
And server on phase C could be running at 0%. Like maybe it's idle.
So it's not balanced.
And the data center starts to get out of balance. And what we have found is that in a cloud data center, it is so hard to predict these patterns. And then in the worst case, you end up losing 7% of the data center capacity. 7% of the DC provision capacity is lost because of phase imbalance. So what we did was we said, okay, so let's do 3-phase distribution to get the efficiency.
Yeah.
But then the 3-phase goes directly into every single server. So it is phase balanced by design.
Right. Each server is balancing itself.
It's phase balanced, exactly. Each server is balancing itself. So there is no dependency on doing some tricks with, rack level phase balancing or
Okay.
you forget about that problem, and you get 7% of your capacity back.
Right. So there's nothing inherently wrong with the DC bus bar, but there's just more stories in data center power distribution.
I think there's another one which is a safety issue. So unless you have some good protection around the bus bar, you could have safety issues with operations. With a three-phase power distribution, it's all encapsulated, it's UL certified, you don't have to worry about it.
Yeah. Okay. And is it useful to people at data center level as well as web scale?
I think so. I think so, yeah.
Maybe.
I think one of the things is that now that we're building out the cloud across the globe, we are building our own data centers, which is the mega scale data centers. But we have to deploy in leased co-locations around the globe as well.
Yes.
Which is very similar to enterprise data centers or DC colos. So this design has been done so that it can go into both locations. So if we can deploy it in a leased colo, anybody else can do the same thing. They can deploy it in their own data center or leased colos.
Okay, brilliant. Thank you very much.
Thank you, Peter.